Um, we said we're going to talk about the solver, and this is the table that we're going to use. I had explained earlier on about this table, but let me try it. So we said we have different investment types for Alex, but we got the bonds, the balance fund, growth, and stocks. And this is the fund distribution. We got the rate of return, the breakout of the portfolio, and the expected return. The expected return is going to be a calculated field because you can see we got a formula here. For those of you who are well versed with accounting, you know this formula for future value. And then we have the total amount. That is the sum of all the expected return. But we were talking about the constraints. And then we said that the total amount should be equal to this. The fund distribution should be greater than 5,000, but less than 40,000. And then the breakup of the portfolio should be less than 35%. So that is exactly what we are talking about. So I want you to click on the solver so that we can have this. So the first thing that when you click on the solver, you're going to get this kind of an interface. You get this kind of interface. So with this interface, the first thing is you set your objective. So we said the objective is the total amount of expected return. So we're going to reference this cell here. That is going to be our objective. And then there are several ways in which you can be able to set your objective. You can set your objective to maximize or minimize, or you can set a specific value for your objective. So for now, let us just we want to maximize. So we want us to get something, anything more than 135, 438.61. And then I got my constraints here. So let me reset this so that you see how to have the constraints. So I'm just deleting the constraints one by one. You can as well reset so that everything goes back, and then you have to start typing from setting the objective. So for you to add a constraint, you'll be required to click on the add button. For you to set up a constraint, you'll be required to click on the add button. So the first constraint is going to be the total amount should be equal to 100,000. So we're going to say that should be equal to 100,000. We don't want Alex to have more money than 100,000 so that he can be able to invest on all these investment types. Next, we can add another constraint because we have a lot of constraints here. And here we're told that the fund distribution for each investment type should be less than 40,000. So we are going to highlight all this. And we say this should be less or equal to 40,000. You can literally type that 40,000 here. So that is 40,000. You can click on add. Then we also have another constraint for this. What we are told it should be more than 5,000. So it should be greater or equal to 5,000. You click on add. And then here we are told the breakup of the portfolio should be less than 35%. So we're told this should be less or equal to 35%. So I think that is the end of our list of our constraints. So we're going to click OK. And then you can see this is the number of constraints that we have. All right. I forgot to show you how we can be able to highlight the changing cells or the changing variables. So for us to be able to achieve our objective, we need to change some variable cells. One thing that you should note is that you can't really change a calculated field or a field that is gotten by a certain formula. So for example, here, we can't really change the breakup of the portfolio because that is something that is calculated. This is 5,000 out of 100,000 times 100 times 100% that is calculated. The same thing to the expected return that is calculated. So the only thing that we can change is this, is the pound distribution, right? That is the only thing that we can change, the pound distribution. So after doing all that, you can choose the method that you want to solve. So the method can be either linear or non-linear. If you look at the simplex LP or linear programming, this is a method that uses linearity. This is a non-linear evolutionary. This is a more complex method whereby you have to define your upper bound and lower bound. We don't really require all that. This is a simpler problem that can be solved using this non-linear method. Most of the times you're going to find that uh, uh, most of the solutions are going to be non-linear unless it is under very special occasion. So I would encourage you to use this, and then you click on solve. So once you click on solve, if the solver finds a solution, it's going to tell you that it has found a solution. If the solver does not find a solution, it's going to tell you that it has not found a solution. Like in this case, the solver has found a solution. And we are told all constraints and optimality conditions are satisfied. So if you click OK, you're going to keep the solver's solution. So when I click OK, you can see that the expected return has slightly increased, but it is still under 135,000. Let us have a look at situations where the solver has not gotten a solution. So I want you to click on the solver, and we're going to change a few things. We're not going to interfere with the constraints. We're not going to interfere with the changing variable cells. I want us to click on the set objective. So our objective is still on this total amount. But this time around, instead of maximizing, we want a value of. So we want to tell the solver, please get us a profit of 140,000. Get us a profit of 140,000 by changing the fund distribution, and then try to see if you can satisfy all these constraints, and then try to solve. So when you try to solve this time around, the solver is telling you that could not find a feasible solution. There's no way it is going to have all those constraints and still 140,000 is the total amount of expected return. So probably when you get yourself to a situation like that, you can try to minimize your constraints. So let us try to get minimize our constraints and see if we can still get that. So one constraint that I want to do away with is the breakup of the portfolio should be less than 35%, because with this constraint, we are not going to have a fund distribution more than 35%. So I'm going to delete that constraint. We still have another constraint here that I think is going to be entrance. to us getting 140,000, which is this, that the fund distribution for every investment type should be less than 40,000. I want the solver to be able to invest heavily on investment types that have got a great rate of return. So I'm going to delete that. And then after doing that, I want to click on solve to see if I can be able to get a solution. Then okay. Well, apparently still no solution has been found. So no solution has been found. So what we can possibly do is, let's look at that. We want 140,000. These are the conditions that we want. What if we have only one constraint, that the subject, that the total amount should be equal to 100%, and we let the solver invest wherever it wants. So I'm just deleting that. So only left out with one constraint. One logical way in which I think the solver is going to do is that, because stocks are a higher rate of return, 16% compared to the rest, so it may decide to invest a lot on stocks, maybe have these investment types with a less rate of return, no money for them, right? So when I click on solve, probably I may get a solution. I'm told a solution has been found. Wow, okay. A solution has been found, and this is exactly what I thought. So what the solver did is that it invested a lot of money on stocks, because with stocks we have a higher rate of return, around 16%, and then it has not invested any single coin on bonds, because the bonds have a lower rate of return compared to the rest. So we have 140,000 as the total amount of expected return. So we have an exercise on the solver that you can get it from the link. So it is index 3.0, that is solver exercise. So this is what we are having. So this is going to be our objective, and we have the different columns, and this is the list of constraints. So we are told that the total budget should not exceed 65%. So what you're going to have is that you're going to set the objective to be 65,000. You're told that the extra cost should not exceed 1,000. We have the extra costs here. And the fixed costs to remain at 2,000. So you don't have to change anything about the fixed cost, because they are already at 2,000. And then the total project cost for every for each project should not exceed 9,600. So this is about the total cost. But if you look at the total cost, this is a calculated field. So what you need to have is, what you need to change is the production cost. But you can still have the total cost not exceeding 9,600 is a constraint, but these cannot be what you are going to change. So what you're going to change here is, you can change the production cost, you can change the fixed cost, you can even change the extra costs, but not the total cost, because the total cost is a calculated field that is gotten by the sum of all that. So I've attempted that.